There are actually several different ways we can classify numbers. We're just going to look at two, rational and irrational. There's a ton of different types of numbers that can be rational. There's few that can be irrational, so it's easiest if we focus on which ones are irrational, and then if they're not irrational, then they must be rational, because every number is going to be one or the other. So let's look at the irrational numbers first. For a number to be irrational, it would be if it is a decimal that never stops, so never terminates. Terminates means stops. So it never terminates, never stops, and never repeats. So if it's those two things, then it is going to be an irrational number. An example would be 5.671392855, and there's no pattern to it, so you can't tell me what's going to come next, and it doesn't stop. These dots mean it's going to keep on going forever. So that would be an example of an irrational number. Another example would be square root of 3, for example. If you were to put square root of 3 into your calculator, you get a decimal. I don't know what it is. You get a decimal that will keep on going and never repeat. So that would be an irrational also. So one way to tell is to put it in the calculator. Another way is make your list of perfect squares. So if I have square root of 1 is 1. Because 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So square root of 9 is 3. Square root of 4 is 2, and so on. So all of these square roots, these would all be rational, because I know what the answer is. Square root of 4 is exactly 2. Square root of 9 is exactly 3. So those are all rational. But any square roots in between here, so square root of 2, square root of 3, or square root of 5, square root of 6, square root of 7, square root of 8, any in between there are going to be irrational. So that's how you can do it if you don't have a calculator to check. If I have a fraction, it will be rational. So if I have, we'll put rational numbers down here. Rational numbers. That would be, so like we just said, square root of 1 is rational. Square root of 4, square root of 25 will be rational, because square root of 25 is exactly 5. 2/3 is rational. 0.6 repeating is rational, because that's repeating means it's going to be 6, 6, 6, 6, 6. I always know what's going to come next, so that's rational. Another irrational number we haven't talked about yet is pi, because pi is 3.1415. I think it's a 9, but then it just keeps on going. There's no pattern to it, and it's never going to stop. So pi is another example of an irrational number. Back to some rational numbers. 2 is rational. -5 is rational. 6.7 is rational. So all of these are examples of rational numbers. Fractions, decimals, square roots, if they're perfect squares. So if we know the answer, like square root of 25 is exactly 5. It's a perfect square. Otherwise, it is irrational. So irrational, those numbers that keep on going forever. There's no pattern. I don't know what's going to come next. Is irrational. Everything else would be rational.